Well, dear friends, in this video I will be explaining you about nuclear fusion. In last video we have learnt about nuclear fission. In nuclear fission I told you when a heavy nucleus like uranium-235 captures a neutron that current into 92U-36, which is unstable, and split into two nuclei of average atom mass, and as bi-energy per nucleon of average atom mass is nearly 8.5 and that of uranium-236 is 7.6 MeV. So 0.9 MeV energy released by the fission of one uranium nucleus. Now here, what is nuclear fusion? I have written just to save the time and just to explain you. The process in which two or more light nuclei, nuclei means plural of nucleus, nuclei. The process in which two or more light nuclei moving very fast collide and get fused together is called nuclear fusion. Well, actually in different videos and books it has been shown that this come and they move and get together like this. So they make one heavier nucleus. So the process of nuclear reaction in which lighter nuclei like deuteron or protons, any nucleus of hydrogen is proton. They combine together to form bigger nucleus. Then energy released, and this reaction is called nuclear fusion reaction. From binary curve we know that bi-energy per nucleon of light nuclei is less than that of heavy nuclei. For example, deuteron has a binary per nucleon 1H1 and helium has 7. So if deuteron combine together or get fused for deuteron, nearly 6 point something energy will be released. And after releasing energy, nucleon get packed more tightly. So whenever nuclear fusion take place, again energy is released. मैं लिखा है यहाँ पर from bi-energy curve. We know that bi-energy per nucleon of light nuclei is less than that of heavy nuclei. So when two or more light nuclei are fused to produce a heavy nucleus, energy released. The energy released per nucleon in fusion reaction is much greater than in fission. अभी I told you example कि binary per nucleon of deuteron is 1.1 per nucleon, while that of helium is 7. So this is the meaning of fusion reaction. There are many examples, many reactions, or many examples of fusion reaction mentioned in books and elsewhere also. Here on the board, मैं इसको रब करता हूँ ताकि आपको आसानी से दिखाई दे. One reaction is there in which deuteron combine together to form helium. So the steps are like this: one H1 plus 1H1, sorry 1H2, deuteron 1H2. They combine to form 2He3 plus neutron. No, sorry. 1H2 plus 1H2, 1H3, sorry. Tritron plus 1 proton plus 4.0 million electron volt energy released. Then 1H3 plus 1H1, 1H2, sorry, deuteron, it gives you 2He4 plus neutron plus 17.6 MeV of energy. So if we add these equations, adding these equations, we get sorry, it is 1H1 here. नहीं यार 1H1 तो नहीं होता, 1H3 plus 1H2 है ना, 1H2 ही है. तो when we combine, we add this equation, so we get 1H3 cancel, we get here, when we add these two, this get cancelled, so 3 thrice of 1H2, 3 deuteron together give us 2He4 plus 1 proton plus 1 neutron plus 21.6 MeV energy released. This is one example, this is one method of expressing the fusion of deuteron into helium. Other way we can write this equation as, alternatively we can write like this, 1H2 plus 1H2 equal to 2He3 plus 0 and 1 plus 3.3 MeV of energy, and then 2He3 plus 1H2 is equal to 2He4 plus 1 proton plus 18.3 MeV. If we add these two together, again we get here, adding these two equations, we get thrice of 1H2. As this 1 here suffix represent as atom number 2 mass number, equal to 2He4 plus 1 proton plus 1 neutron, 0 and 1 neutron, plus 21.6 MeV. Here we have estimated this energy release because in terms of binary per nucleon, but this energy release can be obtained by mass defect. Actually, here the total mass of 2 deuteron will be slightly more than the sum of masses of helium and helium isotope, and nitrogen, that mass defect convert energy is equal to 3.3 MeV. MeV means million electron volt. 1 million electron volt means 10 to the power 6 electron volt equal to 1.6 10 to the power minus 13 joule. MeV is small, but if you take 1 kilogram of deuteron, then it will have 6 into 10 to the power 23 atoms. So multiplying that, we get this thing. So per fission, देखो, it is 3 deuteron combined together to form helium and proton neutron plus this energy. So if we determine per deuteron, it will come out 7.2 MeV. Fusion of deuteron. Per deuteron energy release is 7.2 MeV, 7.2. In case of fission of uranium, only per fission there was only 0.9 MeV energy, 0.9, nearly 1 MeV. It is 7.2. So nuclear fusion is better source of energy. I will be explaining later. So we can find out this energy release by calculating mass defect also, not only on the binding energy. So this is one example. Now we know inside sun, large mass of hydrogen is present in the sun. Initially whole mass of sun was in the form of hydrogen. सन का पूरा मास हाइड्रोजन की फॉर्म में था इनिशियली. बिकॉज ऑफ लार्ज मास ऑफ सन, यू नो हाउ मच इज द मास? 2 into 10 power 30 kg. Now you can understand here, solar system. Sun is the head of family, and there are 9 planets. There are some satellites and meteors and many other things. The total mass of solar system we take, then 99% mass of solar system is present in sun. So there was a strong pull. Due to strong pull, hydrogen fused into each other. I will be telling you just now difficulty in the fusion reaction later. In in the sun, the source of energy is the fusion of protons to form helium, and that reaction here, proton-proton cycle, proton-proton cycle. In the core of sun. There one proton means nucleus of hydrogen plus one proton combined together to form one H2. First they produce neutron plus one positron plus antineutrino plus 0.42 MeV energy. First hydrogen atom means hydrogen nucleus, which is called proton, combined together to form this deuteron. And there again some electrons are present in the sun. So plus 1 E0 means positron, minus 1 E0 means electron, combined together to produce 2 gamma photon. 2 gamma photon plus 1.02 MeV energy. Yes, 1.02 MeV energy. Then 1H2 plus 1H1. What is 1H2? Deuteron, nucleus of deuterium, plus 1H1. It gives 2He3. 2He3 plus gamma photon और plus 5.49 MeV energy. Then 2He3 isotope of helium plus 2He3. It gives us 2He4 plus 2 protons plus 12.86 MeV energy. Now if we try to add these equations, now see balancing of equation. Here 2He3. There are 2 nucleus of helium. There is only one. So we have to multiply this equation by 2. Now this way, here 2 deuteron have come and there is one deuteron. So we have to multiply this equation again by 2. And that way 4H1 these 2H1 get cancelled here. So if we add these together, so 2H1 sorry, ये 2 से मल्टीप्लाई होगा तो 2 2 या 4, तो we get 4 bracket 1H1 plus minus 1E0 because there are 2 positron here, 1 positron, and therefore plus 1E0 is equal to, we get here 2He4 plus 2 neutrino, this is neutrino, plus 3 gamma, and plus my total here come to be 25.76. MeV. But in book, NCERT book, the equation has been given other way in NCERT book, and here it is total 27.5 MeV. And I could not find the difference, why it is there. So these are possible reactions. Now inside sun, hydrogen is being fused, and it is the source of energy in the sun. And you know the amount of energy released by sun is nearly 4 in 10 to the power 26 joule. 10 to the power 26 joule per second. We can calculate this other way also. Using the theory of radiation, emission power. So that way the mass of sun, hydrogen mass, there occur mass, I told you there occur mass defect. So mass defect taking place in the sun is 4 into 10 to the power 9 kg per second. But total mass sun is 2 into 10 to the power 30 kg. So nearly 10 to the power 11 year further will take, this time. How much? Mass of sun, दिखाई दे रहा है? नहीं. Reducing at rate of 4 into 10 to the power 9 joule, kg per joule. It has to produce 4 into 10 to the power 20 joule per second. As a result of this, mass of sun is reducing by 4 into 10 to the power 9 kg per second. So that way, the mass of sun is reducing, total mass sun is in kg. So nearly 10 to the power 11 years will take to get whole of the hydrogen in the core to get fused into helium. And ultimately, when whole of the hydrogen gets fused into helium, then the heat production in the core will stop. As a result of that, it will further collapse and may give large amount of heat due to collision, and finally it will be left a body having no energy inside. I will discuss the difficulties of nuclear fusion in next video because it has become very lengthy. Difficulties in making nuclear fusion. Nuclear fusion is better source of energy. I told you that nuclear fusion energy reached per nucleon is nearly 7.2 अभी बताया था. While in the fission of uranium-236 it is only 0.9 MeV per nucleon. But because nuclei are positive charged particles, they repel. So how to fuse them into each other, that is another thing. Thank you. Enjoy and read books for this. You will get different things in different books.